lunchtime, so opportunities to get yourself a FunCube t-shirt or any of the other items that we've got for sale. Please see me in the shop afterwards.
Could Jeremy Curtis contact me, because I got this envelope of stuff.
Gentleman in the back row.
He's in the back row.
Okay, I'll give it to you later on. Thanks, man.
Okay, thanks, Kieran. Thank you. You've had enough of me by lunch, I guess. Anyway, yes, not only do I want to talk briefly about the DATV on Columbus project, but give you a quick update on some of the other things that AMSAT-UK are getting involved with or trying to get involved with, as well as obviously FunCube 1 and FunCube 2, which you've heard about earlier, which is obviously in the short term taking most of our time and effort. Okay, so starting very briefly with ASAO 2012. There are some in the room who will have heard me talk about ASAO on and off for the last decade. It actually goes back longer than 10 years. ASAO was the European Space Agency's first venture into student satellites, and it never got off the ground. It became SETI Express, which were the bits they had got. Anyway, it's a long story, and they've tried to do it twice again, but now they're having a third go at actually launching or getting built and then launching a 30-kilogram microsat into low Earth orbit. The prime contractor, if you will, is the University of Bologna in Italy, so we will be working with them and a whole load of other groups. Our plan, they are using UHF extensively for their own communications, so we can't use 70SEMS, so we look up and below, up and down, above and below 70SEMS, so we end up with an LV-FM transponder idea with BPSK telemetry, something similar to FunCube. Again, beggars can't be choosers, but that's what we seem to be looking at the moment. University of Bologna are signing a contract with ESA Education. I believe it's actually next week, and then things will start to happen. These are some of the other payloads and systems that are being provided generally by universities, of course, around Europe. You'll see Cranfield are providing deorbiting advice, and our Polish friends are still there with some S-band that we never managed to, well, they'll be used on SETI Express, but never managed to use in anger because the battery ran out. Anyway, so a bit of history. So these are the people we'll hopefully be working with. My apologies to those viewing on the internet. You won't be able to see that, but this is a functional block diagram that David produced 2 or 3 months ago when we were making our bid. It very simply shows a functional block diagram of an L to V transponder with added telemetry. The idea would be that if we can maintain the compatibility of the telemetry on VHF downlink, we can probably run more power than we can in a CubeSat. This is a 30-kilogram satellite. There will be power available, so maybe we could have a real HPA running 4 or 5 watts, and that would be loud. So that would be good. Simple diagram showing the antennas. The ones sticking out generally at the side are the 4 UHF antennas. This thing, they don't like VHF antennas because they're too big, so I convinced them that we can operate with a slightly squashed 2-meter antenna, and taking the idea, I have to say, which I stole from AO51, which had got an LS whip, sort of 2 whips close together, we think we can do a VHF whip with some L-band bits sticking out at the bottom. David thinks we're mad. But we had to get something done quickly to get into the work, to get involved with the work. The exact timescales are not yet known. Final configuration still needs to be finalised. Lots of paperwork. This is going to be an ESA project. So we're obviously open to, this gives lots of new opportunities for AMSAT UK members. If you're not involved in some of our, in FunCube and some of the other stuff we're doing, and would like to become involved, please beat a path to our door. We'd love to get more people. This is a serious point, actually. There are now lots of opportunities, we believe, within AMSAT UK for members to become involved in actually doing stuff in space. And we'll certainly welcome all newcomers. Another ESA opportunities presented itself. The Education Office, again, I apologise, but the Education Office on the 1st of August, a great time to send out a call to universities to say, would you like to put your hand up to do a CubeSat, and we'll try and launch it. But that's what they did, and they gave the universities 5 weeks, which I thought was quite kind. So the responses to this call had to be in by a week or so ago, the 7th of September. Basically, it was very simple. That they only wanted an email, would you be interested in building a satellite, a CubeSat that we would launch? So we put our hand up, of course, and again, it's very long-winded, but the name is CamCube. You haven't heard that before. It would be a planned collaboration between us and Cranfield Space Research Centre. It would be a 1, maybe 2 if they'd let us, but certainly a 1U CubeSat. It would give the opportunities for students at Cranfield to become directly involved in the processes to build and test and verify experiments in space, and they have their own ground station already built, not yet installed, so they could use that as a mission operations centre. We would do the education outreach again, similar to FunCube, and we would try to add a camera so we could do some digital slow scan TV pictures down images, sorry, not pictures, must use the right jargon word, images, Earth images, and through that, encouraging students to be interested in and understand and have a passion for STEM subjects. I won't try and read the rest of it out, but it's an offer that we've made to them. We've emphasised that a lot of it has got technology readiness level 8 or 9, so they can go with us on their next launch. Again, I think you've seen this slide before with a different header, exact timescales not known, final configuration, lots of paperwork and lots of opportunities. So, moving on rapidly from that one, that could be really good news, and I have to say I don't know when we'll know about that one. Good. Moving on from that one, we've got hand TV. This is a proposal that's been kicking around for probably the best part of a decade to have television pictures down from the ISS. Originally it started with the concept of FM TV. The link budget there was dreadful. Since then DVB-S has been invented, and a lot of radio amateurs are already using DVB-S terrestrially, and the concept that's been picked up by AMSAT Italy is to have an S-band downlink for digital video. They've actually managed to get ESA to give a contract to Kaiser Italy to build it. Of course, that's the simple bit. Just getting one built isn't never going to be enough for a project going to Columbus, so there's a lot more work that needs to be done, and I'll whip through all this. But the FM TV, you tend to get a noisy signal. It would be difficult. Digital TV, it's got a much better link margin there. You can see it's better. It's in green. The antennas. The antennas, when Columbus was launched, we managed to get a couple of L-band, S-band patches bolted on to what is now the underside of the Columbus module, which you can just about make out there and there. And they are conventional. Again, they're actually done by University of Wrocław in Poland. So they've been there ever since the Columbus module's been there, and we have not yet been able to activate them to use them. So this is the opportunity that we've got. There's also, they added a VHF, UHF antenna externally to Columbus, so we've got the opportunity to run the school's contacts from Columbus if we want to, and to have the video coming down as well. So that's the whole idea of it. Oh, it marks where those antennas are. A block diagram of the hand TV transmitter. It uses an existing camera that's already on board, probably an existing power supply that's already on board, known as a blue brick. And produce 20 watts of power. That's not bad going. The coax, of course, is fairly long from inside to outside. I think on S-band there's something like 8 dB loss, or 6 or 8 dB loss, so that's a lot to make up. They're planning to use SR devices, SR systems, DVB2 modulator and transmitter, and a nice Kuhn PA. And it would be built in a box that is convenient for astronauts to use. That's a close-up of the antennas as they looked just before launch. I think the atomic oxygen has changed them from a nice white colour to a goldy brown colour, but we don't get many pictures actually, images actually from that point. So if you ever see any up-to-date images of those antennas, there is a science requirement to gather them, because we don't seem to have them. Oh yes, that's the 8 dB loss between the PA and the antenna. one of the difficulties is, obviously, for video you need a stronger signal, a better link budget. So what we're developing, or what they're developing in concept terms, is that we will have a string of ground stations that will hand over the pictures via the internet as the space station goes over. That's their proudly first test transmissions. Where do we come in? Well, as well as the ham TV or the ham video system, which is down here with the camera and the antenna, they're planning to have a D710 there, which is a voice transponder, voice transceiver, which would also have a student experiment attached to it. And then the belief is that we need an S-band beacon, A, to test the antennas, and B, to act as a tracking beacon. And we're working possibly with Andy G4JNT and Charlie G3WDG to build a little beacon unit. So that's work in progress at the moment. It would produce probably 2 or 3 watts out and be very efficient using a GAN device, which I only first heard of a couple of weeks ago, but they're something like 75% efficient. One of the problems on the space station, of course, is although they've got lots of power, their big problem is getting rid of the heat. So anything that you can offer them that is really efficient, that doesn't generate much heat, they go, oh, I'll tick that box. So that's what we're trying to do. 5-watt output, it says there. It's got all the details. Additional contributors welcome. If you fancy building the box and doing some of the work or doing some of the software, you would be very welcome to join the team. Coming on now to things that are not projects, but relate to our activities. Ofcom, our national regulator, has put out a call for input about spectrum release in the range of 143 to 156. That doesn't include the 2-metre band that exists at the moment. It's the 1 meg below and the 10 megs above, if you like. We're working with our friends at BATC to make sure that the RSGB does put a response to that. We'll have an amateur radio response to that. The game plan would be to try and get Ofcom to allow radio amateurs to have access to maybe 1 megahertz, maybe 2 megahertz. The ideal would be between 146 to 148, so that we could develop here in Region 1 activities which are already in the amateur spectrum in Regions 2 and 3. The rest of the world has 144 to 148. And a bit like we developed a use of 6 meters over the years, which has now become a worldwide allocation, we'd be doing the same. BATC are involved because they're already heavily playing with digital video and need some a megahertz or 2 of spectrum. The long-term plan for the youngsters in the room is that we could then, when they get 144 to 148 as an amateur allocation, then we'd have more room for amateur space, which at the moment is compressed into just 200 kilohertz, just at the top end of around 146. That's a very, very long-term plan. So it's like planting a tree for the next generation, or sapling for the next generation. And there's some of their release plans. Responses are due by the 12th of October, so we've got to get a move on. And yes, I've already said all that. Next up is the reform of the UK Outer Space Act. As you will be aware, the Outer Space Act, and I won't go into all the history, but was written at a time when the concept of CubeSats and unincorporated associations such as AMSAT being in a position or having a desire to launch spacecraft wasn't really thought of. The UK Space Agency planning a reform which would do a number of things, but from our point of view would remove the need for us as AMSAT-UK perhaps to try and get third-party insurance for a vast amount of money, because the insurers just can't comprehend whether we can afford it or not, which is another thing. But it is impossible currently in the UK to get insurance for CubeSats, which is largely why there have been no UK CubeSats launched up to now. So we have AMSAT-UK have done a response to that and basically said the proposed reforms are the right idea. But again, you can read all that in your upcoming Oscar news, which has been delayed because of all the work that we've been doing. So it will be out, Jim, at the end of this month. Absolutely, says the editor. So that's just a continuation of description of some of the stuff that we're doing. and planning to do over the next few months. It really forms a continuation of AMSAT UK's existing activities. It's an investment for the future, and hopefully it will give opportunities for new AMSAT UK volunteers to be involved. Be happy to answer any questions. Thank you very much.
Do we have any idea when the Ham TV hardware packages might be up on the station?
Yes, in theory, the TV transmitter is going up on ATV4, I think, in April. That's when it's presently manifested. Whether that will happen, but yes, fairly soon. And because it's a commercial contract, it's not fantasy, it's real. Yes?
Has anybody know this ATV thing going up to the space station? Presumably our satellite boxes that we use, like FreeSat boxes, which are DVB-S, S2, would be able to receive this without an LNB if we put a decent antenna in front.
Yeah, sorry, the question was a normal DVB-S box is operating, its IF frequency is around 2 gigs, I think, and I'm not sure that the frequencies...
They operate from about 1 gig up to 2.2 gigs.
Yeah, but we're operating at 2.4, so there'd still need to be some form of down converter in front of them. But the modulation will be such that many standard broadcast DVB-S boxes will work. Some of those will not work at a slow enough bit rate, data rate, because it will only be a fairly slow video, bit rate. So we will need to select the right box. Sorry, yes, I bow to my TV expert there. Sorry, the older ones are less compatible. Yeah. Okay.
What size antenna would you need for?
What size antenna would you need for getting the link budget is based on a 1.2 metre dish at about 1,800 kilometres, down to about 10 degrees, something like that. I think they're quite pessimistic with their link budget, but there you go. But a biggish dish, but not an enormous one. So there's a question right at the back.
There's a move on terrestrial ATV to use very narrowband co-FDM. Would that be used from the satellite, or would you be using another?
It is what it is. It's being built as by SR system, so it's a DVB-S. Is that very narrow? It's 1 or 2 megabits.
That's yeah. Okay, thank you.
Yeah, I thought it was good. Okay, fine. Well, thank you very much indeed for listening to me again.